Okay, so what we're looking at here is a rational function, and the question we want to answer is this. Find any points of discontinuity. Find points of discontinuity. In other words, we want to find continuity. We want to find the places for this graph, okay, where we are undefined. Okay, that's what a point of discontinuity is. So the only places where you're going to be undefined is where the denominator is equal to 0. Okay? So what we're going to do is take that denominator and set it equal to 0 and see what we get. So x squared minus 2x equals 0. Factor the x out. It's in both terms. So x times x minus 2 equals 0. And then set each piece of that equal to 0. So x equals 0 and x minus 2 equals 0. And so where do we get for our points of discontinuity? We get x equals 0 and x equals 2. When we're graphing this and those two values of x become 0 or 2, that's a discontinuity. The reason is these two guys make the denominator undefined. Okay, and when you're undefined, you're discontinuous. These guys are also the vertical asymptotes. For this problem. So without a calculator, right off the bat, we can find the vertical asymptotes. It's just where the denominator is equal to 0. The second question I want to be able to answer with this problem is find any horizontal asymptotes. Find horizontal asymptotes. And so there's two places that we have to look to check for horizontal asymptotes. And the two places that we have to check are the degree of the numerator and the degree of the denominator. We have to look in those two places for horizontal asymptotes. And there's a couple of rules. Number one, if the degree on the top in the numerator is smaller than the degree on the bottom in the denominator, then you have a horizontal asymptote at y equals 0. If the degrees are the same, like they are for this problem, then the horizontal asymptote is equal to the ratio created by the leading coefficients. In other words, these numbers that are right in front. And so in the denominator, I have 1x squared. So down here, this would be a 1. So for this particular guy, my horizontal asymptote is y equals 2 over 1. We very, 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 very seldom use the number 2 over 1 because we usually will write y equals 2. And so those are the things that we're interested in if we're looking for a point of discontinuity, and then a companion to that is a horizontal asymptote. Okay, we've got another rational function, and it's very similar to the previous problem, except we're going to look for some different things with this guy. First off, we want to be able to describe any vertical asymptotes that we might have. So we want to find vertical asymptotes. We also, in locating vertical asymptotes, we want to look for and find any holes in the graph. And holes, if there's a hole in a graph, it will not show up when you graph it on your graphing calculator. The holes will not show up. So you have to find those on your own. Even if you graph it with a graphing calculator, you have to check for a hole all on your own. And then also, we'll go ahead and we'll find a horizontal asymptote as well. So we can find, that way we can find everything kind of related to a rational function. So this y looks really bad. Okay, so what are we going to do? Well, to find vertical asymptotes, we need to find where the denominator is equal to 0. Okay? And while we're doing that, we also want to factor out the top, because if we can get certain pieces of this equation to factor out, that'll be easier for us in the long run to graph. So what we're going to do is we're just going to factor the top and the bottom. So I've got this 6x squared on the top, 6x squared plus x minus 2. And then on the bottom I have 3x squared plus 17x plus 10. So use whatever method you want to be able to factor these guys. And you need to get comfortable factoring. It's a crucial step to later in life problems. I know that, for example, on the top, 2 has to go with 2 and 1. And I know on the bottom, 3 has to go with 3 and 1 for my factoring. Okay? So now I just have to figure out on the top how to factor. And you know, if I just kind of check a couple things, if I put a 6 here and 1 here, remember that we've got to end up with plus x. And my signs are one's going to be positive and negative. So 6 definitely is not going to work, because 6 times 1 is 7, and there's no way to get back to 1 from there with it that 2. So 6 times 1 is 6. Yes, sorry. Plus 1 is 7. So I just erased the 2. I distracted myself. So we'll leave this 2 right here. So I think it's got to be something along the lines of maybe 3 and 1, 3 and 2. So 3 times 2 is 6. And then also, if 3 times 2 is 6, if I go 3 times 1, that's 3, right? And 2 times 2, that's what? 4. So 4 minus 3 is 1. So I need to get 4 minus 3 to be equal to 1. So how am I going to do that? I'm going to have plus 4 here. So 3x plus 2 and 2x minus 1. And so when I FOIL that guy out, that gets me 6x squared plus x minus 2. On the bottom, I've got this big problem, and so again, it's going to be kind of the same thing. I need to be able to add everything up to get to 17. And if I do a 10, you know, if I take 10 and put it right here, and 1 right here, that's going to be 30. That's way, way, way too much. Okay, so when I do 3 times 10, that's 30, plus 1 is 31. That won't work. So I'll just go with the next one, which is going to be 2 and 5. And again, I need to get to 17. So if I put a 5 here and a 2 here, when I check this guy, I get 3 times 5, that's 15, plus 2, that's 17. So that's what we want. So this is going to be 3x plus 2, and this is going to be 1x plus 5. Now, check this out. I've got a 3x plus 2 on the top and a 3x plus 2 on the bottom. Okay? Since I have 3x plus 2 on the top and a 3x plus 2 on the bottom, it cancels out. Alright? And for this particular problem, since I have something that cancels out of the numerator and denominator, I'm going to have 3x plus 2. When that guy equals 0, I'm going to have a hole. So anytime you have something that cancels out of the numerator and denominator, you'll have a hole where that item is equal to 0. My vertical asymptote then is the other thing on the bottom. So my vertical asymptote is going to come from this guy right here, where x plus 5 is equal to 0. And then my horizontal asymptote, again, I have to look in 2 places every time for my horizontal asymptote. So for my horizontal asymptote, I'm looking at the degree of each equation, top and bottom. And since these degrees are the same, then my horizontal asymptote is going to occur at y equals, and just as exactly like the previous problem, y equals 6 over 3. We look at those leading coefficients. So this guy's 2. This guy's negative 5. And then my whole occurs at when 3x is equal to negative 2, which is x equals negative 2 over 3. So my whole is in red, my horizontal asymptote is in blue, and my vertical asymptote is blue, and my horizontal asymptote is purple. What we want to do on this rational question, this rational function, is we want to find a point of discontinuity. And so if we're going to find a discontinuity, that means that we want to look for a place where the denominator is equal to 0. And that u is really nasty, so it's nasty. That's awkward. Okay, so what we're going to do is we want to look for, then, if we're going to find a discontinuity, then what that means is where this guy down here, the denominator, is going to be equal to 0. That's all that means. A discontinuity is the exact same thing as a vertical asymptote. These are the same types of things. A discontinuity means that your graph has to stop, okay, and then continue on again on the other side of that value of x. So basically it's a vertical asymptote. So what we need to do then is take the denominator and set it equal to 0. So x squared plus 6x plus 9 equals 0. This is where we are. And there's a lot of different ways that you can solve this out. If you're going to do it by hand, then you can factor this guy. So this would be, what times what is x squared? What times what is 9? That adds up to 6. 3. And so we can factor it, and we can find that when we set each piece equal to 0, that we get x is equal to negative 3. That's our single point of discontinuity. And we also know that since we have this point of discontinuity, that this guy right here is also a vertical asymptote. So this guy is also a vertical asymptote. All right. The other thing that we would probably want to investigate with this one, and although the directions on the sheet that you're working on don't say so, is we would want to be able to find a horizontal asymptote as well. And for horizontal asymptote, there's a couple of rules that you need to remember. And everything with horizontal asymptotes is centered around looking at the exponents in the numerator and the exponent in the denominator. And if they're the same, like these guys are, then your horizontal asymptote is the ratio of those leading coefficients. In other words, what numbers are in these places? Ones. So I've got 1x squared over 1x squared. So my horizontal asymptote would be, let's go ahead and asymptote, would be y equals 1 over 1, which is 1. Okay? Okay, so on this problem, again, it's similar to all the other ones that we've worked so far, and it's a rational function. But on this particular guy, we want to find vertical asymptotes and wholes. So a vertical asymptote or a whole. Okay? And so these are the two things that we're really interested in. So to do that, what we've got to do is factor out the numerator and factor out the denominator. Okay? So when I factor the top, I have x squared minus 4. That factors to x plus 2 and x minus 2. Okay? And the bottom doesn't factor at all. It's just x plus 2. And if you'll look at this problem, what you'll see is that x plus 2, there's an x plus 2 on the top and 1 on the bottom. And so if there's 1 on the top and 1 on the bottom, you can cancel them out. They go away. Now, here's why it's important. Because anything that cancels out of the top and the bottom, like this, a factor, is going to be where the hole is located. So we would set x plus 2 equal to 0 to find the hole. And then whatever else is left in the denominator, we would set equal to 0 to find the vertical asymptote. So for this particular problem, there's nothing else down here. Okay, there's nothing else down here. There's only that x plus 2. So there, for vertical asymptotes, this guy would have none. There's no vertical asymptotes on this particular problem. But there is a hole when x equals negative 2. And if you graph this on a graphing calculator and look, it'll look like one continuous graph. And at negative 2, it'll look like all those little pixels on your calculator are connected. They are not. And so this is one of those things where you've got to be able to do this by hand so that you can see what's truly included or not included in your problem. All right, on this guy, again, it's a rational function like what we've been working with. And so the big question that we want to answer for this one is to find the horizontal asymptote. But in practicing finding horizontal asymptotes, we also want to try and find if there's any vertical asymptotes or holes. So all those things are always related to these rational expressions. But the primary question for this one is the horizontal asymptote. Okay, and in order to successfully locate a horizontal asymptote, you have to compare the degree of the top and the degree of the bottom. Okay, and on the case that was on the previous slide, the degree on the top and the degree on the bottom were the exact same. However, another case that could occur is that the degree on the top is less than the degree on the bottom. Okay? And so, since the degree on the bottom is larger, then our vertical asymptote, our horizontal asymptote for this particular problem, since the top is smaller than the bottom in degree, then we would just simply say that y equals 0 for our horizontal asymptote. And that's all there is to it. For the vertical asymptote or holes, we need to factor the denominator out. So when I factor the denominator out on the bottom, all I can do is pull out a 2, and then I set that equal to 0. So again, this is one that you could do by hand, and if you did it on calculator, you would probably struggle to find the exact location of the vertical asymptote because it's not going to occur on a number that we use a lot. Okay, but if you'll notice here, I've got x squared minus 2 equals 0 because I can divide that leading 2 away. And when I do that, I get x squared equals 2. So x equals plus or minus the square root of 2. That is my vertical asymptote. Okay? And on your graphing calculator, you will have a very difficult time determining that exact value because it'll be a decimal, and that decimal, it's hard to locate that precise point on your calculator. So you've got to be able to do that by hand, and nothing on the bottom factors out with anything on the top. So since nothing on the bottom factors with nothing on the top, there are no holes. Okay, so we got a horizontal asymptote at y equals 0 and a vertical asymptote at x equals plus or minus the square root of 2.